Today, you will be learning how to graph a parent function, shift, reflect, and stretch the graph. For our lesson objective today, our lesson objective is to figure out what a parent function is, how do you find the multiplier, and how to use switch a graph. Okay, so for prerequisite skills, you'll need to know the parent function of x squared. So the parent function of s squared goes by, you just get a little table, make yourself a little table, and then you have x and y. So you're gonna go 0, the parent function, if you put 0 squared, it would be 0. If you put 1 squared, it would be 1. If you put 2 squared, it would be 4. And if you put 3 squared, it would be 9. If you put -1 squared, it would still be 1. If you put -2, it would still be 4. And if you put -3, it would still be 9. So to graph that, so now we have the parent function of the graph. So you just connect these points. So you have the 1 graph, and all of them are now graphed. And you can see that the domain is -infinity to +infinity. Range equals -infinity to +infinity. And the y-intercept is 0, 0, as well as the x-intercept is 0, 0. So now you have the translation form of the graph. So as in its actual form, its equation form, it'll be f of x equals a parentheses x minus h to the power of 2 plus k. And that is the equation. So the problem that we're gonna do today is f of x equals 3 parentheses x minus 5 close parentheses to the power of 2 plus 3. So to start off the problem, you must have, the first step is having the parent function. And as we just went over, the parent function is x squared. Okay, so now that we have our parent function, we now have to start graphing the second step. So the second step is to do the multiplier. So what you do is you take the multiplier, which is going to be a. Okay, and in our case, our multiplier is 3. So we'll do 3x squared. So the multiplier really means that it's multiplying all of the y values by 3. So you take all of these values, okay, I'm going to times it by 3. So our first y value is 1. So 1 times 3 equals 3. So you go here 1, 3, and it'd be the same on each side. Now we have to go to 2. We have 2. For x equals 2, y equals 4. Remember, as the parent function said. So 4 times 3 equals 12. Now we have 12. Has to be the same on each side. Okay. Now we have 9. 9 times 2 equals 27. So that's going to be way up here. Way up here. So then you just make your lines. And I just do different shapes for the graph just because you always want it to like stand out, the different type of steps that you have. You want to make it stand out. You want to make it stand out. Like, what's the multiplier part? What's the parent part? What's the final graph part? So we are now here. We've done the multiplier step. Now the third stepping, haha, funny. The third step is going to be shift. Once we've done our multiplier part, we now move on to the third step, which is shifting. So our shift is going to be -5. So your H is always going to do the opposite. So if it says -5, we go to the right, which means +5. If it were to be x plus 5 in the equation, then we go to the left, -5. And then the K is always true. You always do what the actual K says. So for K, you really do go up 3. So now we're going to go shift the entire Y values. We're going to shift each Y value to the right 5 and up 3. So in orange, you can see the final product of the graph. So I moved each of the Y values over 5 and up 3, and that is the final graph. Now it is your turn. Go ahead and press pause and try to do this equation using all of your parent function, multiplier, and shifting aspects that I just taught you. So the equation is f of x equals -1/2 parentheses x minus 6 to the power of 2 plus 2.
So here's your example. Remember number 1 in the parent function, which is in black, you have x squared, which points up. Number 2, the multiplier, is -1/2 x squared, which points down. It's in pink. And for number 3, you shift right 6 and up 2, which is in purple. Now we will give you 3 practice problems. Make sure you do your best, and good luck.